One question that has remained a source of curiosity for us throughout the decades and across civilizations: are we alone? We have examined the skies to understand them. We have fantasized about higher level entities coming to Earth and bestowing their powers on us, yet we have received no scientific proof of life beyond our atmosphere. Does this indicate that we're all alone? Or is it possible that we are the most civilized species in the cosmos? The clues have always been sparse, but now that we have eyes 4.2 light years away from our planet, the answers are starting to come our way. There may be life as we know it thriving in the Proxima Centauri star system, which is located 40 trillion kilometers beyond the solar system in the constellation of Centaurus. Proxima Centauri cannot be seen with the naked eye because it is 500 times fainter than our Sun. Why then does the star system play such a big role in our search for extraterrestrial life? While scouring the star system, our cosmic scouts found 3 planets around the red dwarfs, Proxima A, B, and C. Additionally, Proxima b has shown to be an intriguing, extremely fascinating 2016 discovery made by the European Space Observatory. Every 11.2 Earth days, Proxima b revolves around its star. It's also intriguing since it's in the star system's habitable zone, implying it might have liquid water. The planet's tidal locking to its star, similar to how the Moon is to the Earth, is another intriguing feature. In other words, one half of the planet is always dark, while the other is always sunny and too hot to support life. You could wonder, though, how the planet might be habitable. NASA's most recent modeling work reveals that the heat may be uniformly dispersed by breezes, making the cold and dark side potentially habitable. They would require light if life were to develop on that planet and flourish to become a civilization. Civilizations there may deploy powerful mirrors or demand very brilliant LED-like lights to enlighten their world. And this is where the most potent telescope ever built by humans comes into play. Everyone is aware of the capabilities of the James Webb Space Telescope. It has provided us with some amazing pictures of celestial objects located millions of light years from Earth. However, far more than pictures, the James Webb Telescope successfully found water on a far-off exoplanet. Proxima b is significantly closer to Earth than WASP-96, yet WASP-96's analysis allowed researchers to explore the exoplanet's atmosphere in great detail. Imagine what Webb might find when it turns to face it. NASA will use the near-infrared instrument on board the Webb spacecraft to detect any artificial light present and search for telltale signals of LED light weights and the light from the planet. For 5 minutes in 2019, radio signals were picked up coming from Proxima b's direction. It hasn't been discovered since then. According to astronomers, the radio wave's origin is now thought to have been a human abnormality. However, because the anomaly was never found, it cannot be ruled out that it was an alien sign. It follows the TRAPPIST system in terms of people's interest in whether or not Proxima b is livable. The good news is that NASA has vowed to soon focus on these worlds on the Webb. The scientific community had some nagging doubts about how effectively Webb's equipment would work before it launched, and we now know that, even according to NASA scientists, they are doing better than projected. Furthermore, there is no need to be concerned if Webb is unable to locate artificial light because science is all about inventions, developments, and upgrades. Work on the Webb's replacement has already begun, same as how Hubble succeeded Webb. NASA is working on the Large Ultraviolet Optical Infrared Surveyor, a multi-wavelength space telescope design. At the same time, LUVOIR is a general-purpose observatory concept. Its primary scientific objective is to characterize a variety of exoplanets, including those that might be inhabited. Another objective is to provide a wide spectrum of astrophysics, essentially Web 20, from the reionization epoch through galaxy formation and evolution to star and planet formation. While it will take another 10 years or so for this to reach space, for the time being, the JWST is exploring our universe like never before. The side-facing light on tidally locked planets like Proxima b reaches boiling temperatures and continuously produces hurricanes. As a result, there appears to be a small area on the planet where life, if feasible, may exist. Since Proxima b is likewise somewhat close to its star, oxygen and nitrogen can escape from its atmosphere, depriving the planet when hydrogen is added to 2 necessary components for life. Even worse, it can lose all of the liquid water. But there is a lot about alien worlds that we don't understand. The forms of life that exist in the immensity of space may not even include those that exist on Earth. Hotbeds in the seafloor research indicate that life can endure temperatures just slightly higher than 120 degrees Celsius. At temperatures between 120 and 140 degrees Celsius, DNA molecules lose their integrity under surface circumstances. Additionally, life as we know it is impossible without DNA. However, we are aware that even at these extremely high temperatures deep under the Earth, there are still plenty of carbon, hydrogen, and other necessary building elements of life. Understanding the depths of our planet is necessary for us to comprehend the depths of space. For the time being, we have Webb, and with its assistance, astronomers will be able to visually study Proxima b and further explore the possibilities of life there over the coming decades, years, or even months. It might provide an answer to humanity's fundamental question: are we alone? Astronomy has entered a brand new chapter, and we are fortunate to be alive during it. We have reached a crossroads in our search for life. In our Milky Way galaxy, many planets have been found, many of which are Earth-sized and orbit the respective stars in habitable regions. We are aware of the trillions of planets in the cosmos. Our telescopes on the ground and in space, as well as remote sensing technology, are getting stronger. Yet, the only life we have seen thus far is right here at home. We currently gaze into space and hope someone, or something, will return our gaze. James Webb Discoveries. One of JWST's much heralded capabilities is the ability to travel back in time to the early cosmos and observe some of the first galaxies and stars. The telescope was put into operation on Christmas Day 2021 and is currently 1.5 million kilometers from Earth, has already discovered the most distant and early galaxy known. When two teams independently examined JWST images from the GLASS survey, one of more than 200 science programs planned for the telescope's first year in space, they discovered the galaxy. Both teams, one led by Rohan Naidu at the Harvard-Smithsonian Center for Astrophysics in Massachusetts, and the other by Marco Castellano at the Astronomical Observatory of Rome, found two particularly distant galaxies in the data, one so far away that JWST detects the light it emitted 400 million years after the Big Bang, and the other, dubbed GLASS Z13, seen as it appeared. Both galaxies appear to be quite small, perhaps 100 times smaller than the Milky Way, yet they exhibit surprisingly high rates of star formation and have more mass than is typical for galaxies their age. 1 billion times that of our Sun. It even appears that one of the newborn galaxies has a disk-like form. More research will be done to dissect their light and determine its qualities. The picture of the galaxy cluster that President Biden exhibited and that Pascal and Mahler examined conceals more early galaxies. The clusters known as SMACS 0723 is so massive that it bends the light of farther off objects, bringing them into view. Up to 16 distant galaxies were discovered by Pascal and Mahler. Their exact ages are unknown. These galaxies have been magnified in the image. One distant galaxy in the image, a speck of light that appeared 700 million years after the Big Bang, was examined more closely by the telescope. JWST's spectrograph found heavy elements in the galaxy, including oxygen. Light's being found, newer and more interesting galaxies. Things are changing fast, and it seems our minds need to catch up with it. So what do you think about these new discoveries? Let us know in the comments below.